Okay, actually, let me just start recording here. Okay, ladies and gentlemen, let's begin with our tutorial for today. So the tutorial is a social grants program, and it is very similar to lecture 19 in the sense that it's structured like a second semester test or exam. So it is really beneficial to you to try and do this on your own, or attempt to do this on your own without relying too much on what it is that we do in the tutorial today. And so as you know, the story normally starts off at the top, which just gives you a sense of who your client is. So in this particular practical tutorial question, it's about the Department of Social Grants being interested in maintaining records. Typically in any semester test, it will be about somebody asking you, please create a program for us, and that involves doing the design and the programming. So the story is really just that. At the top, they tell you this is your client. They essentially want you to make a VB program that will contain records, and it will be arrays of record structures. And so if you look at this, it is about how well it is running its social grant pay points, and they have approached you to design and develop a Visual Basic application for this purpose. Any decimal values must be displayed up to 3 decimal places, and this is very important. So here in this particular question, they are they are telling you to display any values that are doubles in the form of up to 3 decimal places. So there already you should know, okay, the format command is going to be needed, and if there's anything to do with double values that need to be displayed, you shouldn't round them off. You should rather display them using the formats command. Right. So number one, question 1 in a semester test, and you will see that in the practical that we give out to you later today. The practical will be a previous semester test, and the format will be, question 1 will be a table that tells you what the record structure is supposed to look like. So in this particular example, it says define a record structure that will store the following information on each social grant pay point. So if we were to look at the let me just get my laser pointer here. Okay, so if you were to look at the structure of this this particular table, you'll see that this overall table describes information fields relating to each social grant pay point. So what you should pick up from this is that you are going to have a data structure that will be on a social grant pay point. So you can call it pay point perhaps. And this pay point will comprise of 1, 2, 3, 4, 5 fields. So there are 5 fields for the pay point record structure. But inside this pay point record structure, you can see that in addition to the location, rent, and then the information for each counter and the most served average and rating, there is a separate record structure from here with these 3 bullet points, because it is the information for each counter. So there will be a second record structure called counter. So it is a counter at the pay point which must have the following information: staff manning that counter, the people served per day at that counter, and the most people served in a day. So from this, hopefully you pick up that, oh, hang on, because it is this table is a record structure containing information on each social grant pay point, you should know that, well, this record structure, this overall record structure will be an array. It will be a dynamic array. And then inside each social grant pay point, they say information for each counter. So the magic word that you should try and look for is the word each, or later on you will see per. Now, each counter means that, okay, counter is not just one record structure inside one pay point, because one pay point may have multiple counters. Think of going to the post office. The post office is an example of a pay point, but you don't just have one counter at the post office. The same as if you were to go to ShopRite. At ShopRite, there are multiple tills. So in other words, there are multiple counters at this pay points area. All right, so counter is an array, and then inside each counter you will have staff, but then you have people served per day. So the idea is, you can see that we want to know how many people were served. So how many people did this counter help out each day effectively? So you can see that people served per day is also an array, and in case you're not sure whether it's an array or not, you can see that the example field demonstrates that people served per day, the values for input would be 10, semicolon, 15, semicolon, 22, and so on. So this is indicative of the fact that this particular field in the counter record structure happens to be an array. Then you've got most people served in a day, and you can see that these fields down here are calculated. Now, it's important that you realize that you can't just start your design looking at question 1 and say, yes, I've got this, I figured out what my record structure should look like, because these fields are calculated. So you need to read the rest of your question in order to figure out what kind of information these are actually going to be. However, you can see that in the type column, we've already specified that these are going to be an integer, this is going to be a double, and this is going to be a string. Now, in terms of our design, what I am going to do is, I'm not going to spend too much time going through all the inputs, outputs. I think by now you're pretty good with the inputs and outputs with in your own designs. Today I would like to focus specifically on just drawing out what the record, the data structure should look like, as well as working out how to come up with data, test data for this particular problem. But let's quickly go through the rest of our question so that we can get a sense of what it is that we need to do. So over here, you will see that it says question 2, and question 2 is typically going to be like this. It's going to involve you being told, listen, there are so many dimensions, and these are what the dimensions are for, and always that you can assume that these dimensions are the same throughout. So if you look at question 2, your program must allow the user to specify the number of pay points. So in case you didn't pick up from question 1 what your dimensions are, this will confirm it for you. So you've got the number of pay points, that is one dimension, the number of counters per pay point, so that's your second dimension, and the number of days per counter, and that is your third dimension. And then this statement will you can always expect this in Informatics 1A at least. You may assume that each pay point has the same number of counters, and each counter is monitored for the same number of days. All right. Then question 3 will be more or less the same across, and hopefully you're picking up that this is really similar to lecture 19, and it is really similar to the past papers that we're going to start throwing at you from now on. And please remember that next week, Monday, is a public holiday, as is next week Friday, so there won't actually be a tutorial next week Friday, and there won't be a practical next week Friday either. Your practical that we release to you today will be due in 2 weeks' time. All right. So anyway, the user must be able to input the necessary information for each pay point. So remember that each pay point should give you a sense that that is the outermost record structure, and there will be information inside each pay point that includes information on each counter at each pay point. Then here it says, for each counter at each pay point, calculate, store, and display the most people served in a day. This is the highest number of people served in all the days for that counter at that pay point. So if you take a look at this particular question here, we can see that this tutorial starts right off the bat with a calculation that involves finding the maximum in each array. And you must be aware that your semester test can be like this. You know, you must be familiar with working out maximums. You must be able to find out totals, averages, etc. Because these sorts of calculations can appear in any order in your particular problem. And on this note, the minute we start with these calculations, you should be aware that these questions cannot be answered out of sequence. They actually are typically answered in the order that they are presented in. So if you find that you're struggling with question 4, my suggestion to you is to try and get question 4 as correct as possible before proceeding to question 5, because question 5's answer will likely depend on your correct answer from question 4. All right. So question 5 then says, for each pay point, calculate, store, and display the average most people served. This is calculated by considering the most people served in a day across all counters at that pay point. Then you also have your usual table, question 6. Okay, write a subroutine. So unlike your lecture 19, your lecture 19 had a function, and now in your tutorial you're asked to write a subroutine instead called calculate rate that's given a double called input. Okay, so your parameters are, it's a double that is called input. So already we're giving you instructions. You have to call the subroutine calculate rate, and you have to call the double parameter input, which, and then here it says returns in quotation marks a string based on the following. And the reason why returns is in a quotation mark is because subroutines, as you very well know at this point, is that subroutines cannot really return anything. Functions return values, but this means that you are going to have to use any suggestions? Please just type it out in your chat window. Any what you're going to have to use here? No suggestions? Okay, by ref, wonderful. Okay, so a few of you are realizing that, well, because there needs to be a return in a subroutine, you're going to have a second parameter, and it doesn't tell you what to call it, so you can decide what it must be called, but it must be by ref in order for it to return a value. Okay, excellent. So here it also says that it must use a select case to answer this particular question. Now remember, this is just a subroutine. You're going to write the subroutine, and you are then going to use it at some point later on. And this question ends at question 7, and it says, for each pay point, calculate, store, and display their rating. The rating is calculated as follows, and it says use the subroutine. It's not a function. Use the subroutine in question 6, which is, and then as you can see here, this basically reflects the subroutine in question 6. You still have the value 0 to 50 here, so it's exactly the same comparisons. The only difference here is we're telling you that the values that you need to work with when you pass it to the subroutine is that you need to pass it the average most people served over to this input into the subroutine, and in return you should either get a bad, good, or excellent, which will represent your rating. Okay, so this is effectively your question for this tutorial. And I'm going to begin by going back to my record structure here, and I'm going to put my iPad here on the side. All right, and I am going to all right, so I'm just going to have that here like this. Okay, let's do that. And I'm going to begin by drawing my data structure. So if I were to draw my data structure, I mean my record structures, so I'm going to have my record structures here. Okay, remember you would have done your input and output, but now we're going to start with my record structure. And with my record structure, I am going to start with the innermost record structure, which is counter. So over here, I am going to have a counter record structure. So I'm going to call it counter rec. And please note, your record structures should always be named in such a way that it indicates it is a singular item, because remember, you have a record structure defines one of that particular type, and then you will have an array which will have multiple instances of that type. Think of your data types that you already know. You know string, you know integer, you know double, and they are all singular because that is one string, that is one integer. And if you want more than one integer, then you would define an array of that integer. So the same thing must happen with your record structures. It must be singular. And remember that for our purposes, we are going to use plus signs, and I've already indicated that there are 3, and the reason why there are 3 is because I can count here that each counter has, well, 1, 2, 3 fields. So over here, I'm going to put in staff, and here it says it's a string, so I'm going to put in string there. Then it says people served per day, all right? So maybe I'm going to go P served, all right? And then I'm going to put in open bracket, close bracket to indicate that this is an array, and it is of type integer. Then I'm going to have the most people served in a day, so I'm going to maybe go M served, and that is a single variable of type integer as well. All right, that is then my record structure for the counter. And I'm going to move it up here a little so that we've got the space. Then I'm going to draw my data structure for the pay point. So I'm going to put in pay point rec, and again just count, because I think one of the biggest mistakes that someone can make, and it's a silly one, is if you don't read your question carefully or you miss one of these fields. Now, having said that, ladies and gentlemen, if you find that when you define your record structure, should you look at the question and see, well, I noticed that there's 1, 2, 3, 4, 5 fields here. Can I have less fields in my data structure when I draw this? And I think by now you should know the answer is definitely no. Really, really no. You should not have less. Can you have more? Well, you can have more, but it's still wrong. All I would say is that more is better than less. However, they are both still wrong, and the correct answer is whatever we have here. If we have 5 here, you must have 5. Okay, so all I would say is that if you have more fields than you have, then it's not the end of the world, but we would not really be very happy with what you're doing, because we would then think, why are you confused? Okay, so I'm going to have my 5 fields here. Here are my 5 pluses, and the first one is location, so I'm going to make that a string. I'm going to have rent, which is an integer. And then this next one is information for each counter. So I'm going to have counters, open bracket, close bracket, because it's going to be an array. And remember, the important thing is that you use the same name in your field here. All right. And then you're going to have your most served average. So I'm going to go M average, and that will be a double. And then we're going to have rating, all right, which is a string. All right, so ladies and gentlemen, that is my 2 record structures over there at this point in time. Does anyone have any questions with regards to what I've done so far? If you are shy, you can quickly just type in the chat window that you're okay with this, or if you have any questions. Silence. Anything? No? Okay. Since I'm getting the silent treatment, I am going to continue with the the test data, how I would go about doing a test data. Now, my suggestion to you is that you are not allowed to really work with the computer in the first 20 minutes. But I find that what's really useful is to use something like Excel to work out the test data, to get a sense of what it should actually look like. But if you don't have Excel, then we can go the old-fashioned way. And so I am going to do that here. I will have my test data here. Okay, so test data. And this is what I'm going to do is I'm going to work off this diagram here. And before I do that, I'm going to actually draw what the record structure should actually, well, what the record structure I would draw what one pay point record structure looks like in memory. So please note this is not part of the data structure, but I'm drawing what the structure looks like in memory. Okay, so I'm drawing what one pay point looks like. So one pay point will likely look like this. There will be a location. Okay, as you can see here, there's the location. Then there will be rent. Okay, because remember, one pay point has a location, it has one rent, then it says it has counters, which is an array. So what we need to do is, I'm going to leave out the space here, okay, counters, and then I'm going to have MAV and M and a rating, and those are single values, so I'm going to have MAV and I've got rating here. Now, counters is a array. So what I will do is I'm going to just, for the purpose of right now, I am going to draw, say, 3 such counter record structures in my one pay point. But this is just this space here. This space here is counter 1. And this space here is counter 2. And this space here is counter 3. Right. We need to actually draw out what the counter actually looks like inside. So if we look at this, we can see that, well, each counter has actually 3 fields. So I could technically, okay, maybe I must use red here. I could technically, for this particular counter, draw out that there are 3 sections in this one counter. And I can do the same for this counter and this counter. But what happens inside each counter? So if you look at it, well, it would be staff. Okay, the name of the staff at counter 1. It would be the name of the staff in counter 2, and so on. Then if we look at P served, that is an array, but below there is M served, so I'm going to put M served here, M served here, and M served here. But please note, these M serves, the most serves, are actually one single value belonging to each counter. Then when we have the P served, it is again an array, but it is an array of integers. So for my purposes, I am just going to leave it as, okay, fine, P served will be an array. So I'm going to put in P served, but I am going to indicate that there is maybe 3 so there are 3 days in my example here. So each counter has 3 people served. Well, there's 3 days that they monitor for how many people are served. Or maybe it could just be a ... So we don't really know whether it's 3 or not. But the idea is it gives us a sense that this is an array. Okay, so this is an array. This happens to be an array. This happens to be an array, and this overall one can be an array as well. So, having said that, we can now look at our test data. So, when you come up with your test data, the first thing I would suggest you do is you need to figure out for your test data, how many pay points are there, how many counters per pay point there will be, and how many days each counter will be monitored for. And Mr. Labia has mentioned this as well, and I've mentioned this as well, and the idea is please don't use the same values over and over again. So for my purposes, what I will do is I'll say there are 2 pay points, there are 3 counters, and there are 2 days in each of the counters. Right, and I'm going to show you how to do one of them, but the idea is you should then do a second set where perhaps you then say the pay points there are now 3 and the counters are 2 and the days are maybe 3. So what you're picking up is that the values are different each time. Okay, so these are different dimensions from here. Okay, so it's 3, 2, 3. So if there is anything wrong with your code, actually this will likely pick up the issue. Right, so keeping this in mind, this is what a typical record structure should look like in memory for your pay point. We are effectively going to draw the same over here. So I am going to just mention here location. Okay, this is just so that I can keep track of what each one looks like. Then there is a rent, then there is staff, and there will be the people served, and there will be the most served and the most served average, as well as the rating. And then I'm going to draw my record structures. Now over here I've decided that there are 2 pay points, so I'm going to split it up like this. Alright, so that's my pay points. I can draw my lines here to indicate that this is each line provided. And if you're asking where I get these particular pieces of information from, it's basically these fields here. I've written these fields down. All right, so over here with our location, effectively I am going to provide the name of location A. So this is pay point 1 effectively, and this is pay point 2. Okay, so each pay point has a name, so we can say A, B. Now please note, this doesn't really matter. When it comes to strings, normally we just put in A, B. You don't have to put in a huge name for anything. Then the rent, you can if you look at the question, rent doesn't really matter. So because we're just asking you to input the information in, so you can even put in 1 and 2 if you really wanted to. Now staff, remember this part here, this is part of an array. So then we look at this and say, oh, counters, we're going to have 3. So I'm going to split pay point 1 and pay point 2 into, this is counter 1, this is counter 2, and this is counter 3. And I will do the same for pay point 2. So this is counter 1, this is counter 2, and this is counter 3 of pay point 1 and 2. Right, so then we can see that for staff, each pay point, each counter at each pay point has a staff. So it's just a name. So I'm going to go A1, A2, A3, B1, B2, B3, because each counter at each pay point has a staff number. Then the next thing is the people served. However, the people served is also an array. In fact, it has to be 2. So I'm going to split that up here so that it is the number of people served for day 1 at counter 1 in pay point 1. Alright, and so I'm going to make up some values there, but I'm going to leave that there for now. But please note that these are all calculated. Okay, so this part, this section here is calculated by your program. And the idea is when we come up with test data, we need to make sure that the values that we put in here, we then calculate, and we know that if we ran our program and we tested it, the information in the green space for our program will produce the same values in the green space as we do if we had used the values we put in our yellow space. So what I've done is I've said, okay, I'm going to have to come up with values. So I'm going to put in 10 there. I'm going to put in 15 there. I'm going to put in 120 here. And I'm going to put in 16 there, 15, 18, 11, 12. Please note I'm making these values up. This is really so that when I enter these values, when you come up with this test data, you must input these test data values into your program to see if you get the same correct result. Now, remember that the most served is actually calculated by determining which of that particular array. So of this particular array, what is the maximum value? So in this case, it would be 15. Of this one, it would be 120. This one would be 18. This one would be 12, 15, and 99. All right. And then you would perhaps need to get a calculator at this point to work out, well, what is the maximum of what is the average of 15, 120, and 18? And I've actually pre-calculated it. So it's 51 there, and it is 42 there. And then the rating, this will depend on you having looked through your table. So if you look through your table here again, you can see that, well, if it is between 0 to 50, you should get bad. And if it's in between, it is good. And if you've got more than 80, it is excellent. So you'll see that I've got 51 and 42. And this is actually a bit of planning beforehand. I deliberately made sure that my values here, which were being compared, will result in different ratings. Because remember, you're trying to test your program. So you can see that I've essentially ensured that my values that I input here are in such a way that it produces 51 and 42, which happen to fulfill at least 2 of these 3 possible ratings. So this one would be good, and this one would be bad. All right. And so, ladies and gentlemen, that is how I would have created my test data. As usual, I will upload this example of the test data up onto E4U, so you can then perhaps my suggestion is please try and make your own using this on your own. Okay, and for those of you who want to prefer doing it in Excel, well, please feel free to do it in Excel if you have Excel. Please note that you all have access to Microsoft Office for free, and if you don't actually know how to get hold of it, please consult the general learning guide that is available on Eve as well. Okay, so at this point, do we have any queries or questions? No? Are you still there? Are you so happy with the president's announcement last night that you are not quite here? You're here in body but not in spirit. What's going on? No? No question. Okay, all right. So let's actually start with the Visual Studio programming. All right, so I think some of you are like, yay. Okay, so let me just get rid of this. And let me get rid of this. And let's put in our form. Okay, so let me just give me a minute to close the things I don't need. All right, so let's look at our program. Now, ideally, you want to have worked out what your form looks like. However, you know that this program will have a number of buttons. So I'm going to put at least one button there, and it's going to have a UJ grid. All right. And I personally prefer to do this, but this does not mean that you have to do it the same way as I do. And that is, I like to actually not use input boxes to record what my dimensions are. And the reason why I do that is so that when I type in my dimensions, I can actually see at all times what the dimensions are. Okay, so there are my 3 dimensions. Okay, and then there's a button for initializing. And then just keep this in mind, there's 1 button for initializing, then there's 1 button for input, there's 1 button for calculating the most, then there is a button for calculating the average, and then finally there is a button for calculating the rating. How do I know this? Well, just memory. But if you look at this in your design, hopefully you would have picked up that, well, first and foremost, there is the button for initialization, okay, figuring out what the dimensions are, capturing the dimensions, and then allocating the space and resizing the array correctly. That's 1. Number 2, input. That's the second one. Okay, the third one is calculating the maximum. That's 3. Working out the average. That's 4. And then this one doesn't deserve a button. It's not that it doesn't deserve a button. There is nothing to do here. You're just writing a subroutine. So that's 5, the actual calculation. All right. So over here, we go back to our program. You can see 1, 2, 3, 4, 5. And I'm just going to make sure my buttons are nice and tidy here. And so with all my controls on the form, I am going to dismiss my toolbox. I'm going to go to my form here now, and I'm going to make sure that I don't leave anything by its default named. One thing that's actually quite agitating is that you leave your form as form 1. Please don't make that mistake. So here I'm going to call it SG. This is the form social grants, and I'm going to change the name. So in my text, the social grants program. All right, then the UJ grid, I'm going to call it GRB, and it is actually pay points and counters. So I'm going to put in PC. Okay, we can leave that there. All we really need to do is change the name of the grid. You don't have to change anything else. Then for your text box, you're going to call it TXT pay points. I'm going to call it TXT PP. And then over here, I'm going to have TXT counters. And I am going to call this last one TXT days. And then with my label, I will not change the names, but what I will do is I'll change the text. So it will be number of pay points. All right. And this one will be the number of counters per pay point. All right. And then this last one will be the number of days per counter. All right. So there are my inputs for initialization. Then with my buttons, I'm going to call it BTN initialize. I am going to just name everything first. BTN input and BTN calc max and BTN calc average, and this last one is BTN calc rating. All right, then over here I'm going to go down to my text and I'm going to say initialize program. So you can call it what you want as long as it makes sense. Initialize program. Then there's also input data. The next one is calculate most served. And this one is calculate average. Calculate average served. And finally, this last one is calculate rating. All right, So there is my user interface all done. So I can now move on to writing my code. So I can say goodbye to this, and let me just double click on this button so I can at least get into the user interface. All right, so remember, first things first, you need to set your option statement. So option explicit on, option strict on, and option infer off. Now in your practicals, you typically have that comment at the top that indicates that this belongs to you and so and so. You don't have to do this here. Don't worry about it. All right. Now, once I've set the option statements, then my next thing I would do is I would define my record structures, because this is question 1, which is defining record structures. Now please note, I would suggest you do this. I would suggest that you write comments to indicate where your questions are, where the answers to your question are, so that it makes it easier for us to find these things. All right, so as we recall from our design of our data structure, we have a counter record structure and we have a pay point record structure. So I'm going to begin by private structure counter rec, and then make it public staff string, and public p served, which is an array, as integer, and public m served as integer. And because this is a dynamic array, I am going to make this I'm going to indicate here that it is NDAYS, okay, to indicate that this will be a number of days. So already I'm determining that my dimension variables, one of them is going to be called n days. Then I'm going to define the pay point. So I'm going to have, what's the difference between p served and m served? So if you go back to our design, which I've already closed now, unfortunately, but p served is the people served per day, and m served is the most people served of all the days at that particular counter. Does that answer your question? Okay, all right. So let's proceed. Sorry. Ooh, okay. So we've got m served as integer, and wait, where am I? Okay, I'm here now, and then I'm gonna have pay point rec. And with pay point rec, I'm gonna have public location as string, and public rent as integer, and then we're gonna have public counters as, and then remember here, counter rec is the name of our record structure. So there I've got counter rec, and then public mav, which is of type double, and public rating as string. Now over here I will do the same. I'll indicate that this array counters is of the dimension in counters. Okay, then this is basically our record structures defined, but in addition to this, we are going to need an array of pay point. So I'm going to have private pay points, open bracket, close bracket, as pay point rec. And remember, you only need an array of pay point rec. You do not need an array of counter rec, because you've already defined it on line 15 here. So over here, I'm going to indicate that this is NPP to suggest that there are these 3 dimensions. Right, so I would also then put in NPP, which is one of my dimensions, then n counters as well as n days as integer, because these are our dimensions for n num pay points, counters, as well as days. Right. Moving on. So this effectively is question 1's answer. Now, how do we proceed from there? Well, we should actually then move on to question 2, which, if you recall, question 2 is your program must allow the user to specify the number of pay points. Okay, so that means if we go back to our program now, this button where we allow the user to specify our pay points is question 2. So over here, I would then say this is question 2. All right, and then I'm going to obtain NPP is equal to cint txt pp.txt, and I've got n counters is equal to cint txt counters.txt, as well as n days will obtain the value of the dimension from txt days.txt. Okay, so that is just to obtain the dimensions from my user, because they would have typed it into the text boxes. But you know, at this point, once you know what the dimensions are, you are going to have to, number 1, resize the array, as well as number 2, resize the grid and actually label what you can. So what I will do is I will then specify, as for my comment, I'm going to say resize arrays, and I will also have something that will resize the grid and label it. Right, so to resize the array, remember that our array record structure is, first and foremost, I need to start with the outermost array, because pay points contains everything else. I'm going to begin by resizing pay points. So you go redeem pay points. And what do you redeem pay points to? Well, you must remember that you've decided here that pay points will be of dimension NPP, counters of n counters, and p served as n days. What this means is that throughout your code here, you must make sure that the value inside pay points will only correlate to NPP, the counters will only correlate to n counters, and p served only to days. So if you're using any variables like in a for loop, you must remember that that for loop needs to, if you're going to use a for loop for pay points, it must be a for loop that corresponds to NPP. So over here, what do we want to redeem our pay points to? NPP, because there are NPP pay points at this point in time. But now we can't stop there, because if you stop there, your program is going to crash, because you still need to resize the counters that are in that pay point, and you need to resize the p served array that is inside each counter of that pay count, well, of that counter at that pay point. So the next thing you actually have to do is you need to then use a for next loop to navigate through every single pay point so that you resize the counters correctly. So I will now have for, and then I'm going to say for p as integer is equal to 1 to NPP. So note, we've just got NPP here. You are definitely going to have a for loop that goes through each NPP. Okay, and inside here, you're going to then go redeem pay points. And here, one thing we normally pick up is a common mistake is people go NPP here dot counters to n counters there. Now, can you all, can someone or any of you type in the chat window? Let me know what does this code actually, what does this line of code actually do? Why is it wrong? Besides you telling me because that's NPP. Yes, it shouldn't be NPP, but why is it wrong? Well, the first question I would perhaps ask you is, how many times will we be resizing counters? We're going to be resizing counters NPP times. So it's not that it's not doing it only once, it's doing it. So if there are 3 counters, there will be 3, it will be done 3 times. Yes, exactly. You are correct. Okay. So AR Ogden, you are absolutely correct. It's just going to redeem the counter for counter for pay point NPP. So if there were 3 pay points, it's going to go, hey, pay point 3, you have so many counters. Hey, pay point 3, you have so many counters. And the idea is not to only resize the counters for the 3rd pay point, if there are 3 pay points. You want to do it for pay point 1, 2, and 3. And so if you do find that you've got this mistake, please make sure that how would you know you're making this mistake? Because maybe you're just writing this code and then you run it. How would you know while running this code that this is a possible reason why your code is wrong? Well, you will pick this up when you are inputting the information. So when you get to the code where you capture the information from the user, you're going to find that you are able to capture the name of the pay point. You're going to be able to capture the name of the rent, how much the rent is. But then you capture the information for the first counter, your program is going to crash. And I would suggest that you do that. All right. You won't really get an out of range error, so to speak. You're going to get an error that indicates that the counter at that pay point doesn't actually exist. So perhaps I should leave this error here so that you can see how that actually happens. All right. Now remember that each counter also has a P served array. So I'm going to have a C for C as integer is equal to 1 to n counters. Okay. Next C. So please note the for loops when we're resizing the arrays. It happens all the time. This is a pattern you should pick up. After resizing the array to a certain dimension, what follows is a for loop that is of that exact same dimension. So over here, you'll notice that I've just resized the array to n counters. What follows is a for loop that goes to n counters. So over here, I'm going to read them, and this time I'm going to actually do this correctly. I'm going to say it's pay points P dot counter C dot, and then you go P served, okay, and P served will be in days. Now, having done this, please, ladies and gentlemen, do not then go, oh, okay, now I'm going to go for D as integer is equal to 1 to n days. Next D. My question is, why do I need this? When would I need this? Right now, I don't need for D as integer is 1 to n days, because are there any arrays inside the P served array? Are there any arrays inside this? No. This happens to be an array of type integer. There's nothing inside this array. So because there's nothing inside that array, do not do this. This shouldn't be here. And if you find yourself putting that in there, you need to ask yourself, why are you doing it? Are you just, please don't be caught up in the, oh, we just resized this array. There's a for loop that comes after it. Oh, we resized this array. There's a for loop that comes after it. The only reason why we need to have a for loop that follows after resizing an array is if that array contains another array. pserv does not contain another array, so that is out. All right. Then the question here is, with for loops, do you not have to declare the indexer? Right. That is typically how one would do it. So you would normally want to declare your variables. So you would normally go dim pc as integer. Yes, you would. However, the reason why I did not do that is because you will notice that this particular for loop is done slightly differently from how I usually do it. But Mr. Lebier does this a lot. And that is, he actually goes and adds as integer inside the for loop. And when he does that, he's actually declaring P as an integer already. Okay, so if he does it this way, he does not have to then do what I've done now on line 27. Okay, look, please note this is a matter of style. If you feel more comfortable doing line 27, then please don't add this. Okay, this is not necessary because you've did P and C on line 27 already. Otherwise, you will have an error. All right, so that is us declaring all our memory for all our arrays. And remember that this is wrong, but I'm going to leave it there so that we can see what will happen because we've left it this way. All right, now that is for the arrays, and so we now need to revise our grid. So the first thing we would do is we would say, well, grid pc.rows is equal to n pp plus 1 because we only need one row extra for the labels. But when we now come to here, how many columns do we actually need? Well, we know that it is n counters plus at least 1, but we need to go back to our design, which we didn't really do, and so we're kind of naughty that way, and that is we need to figure out how many extra additional columns do you have. So we need to figure out, well, input data, there's no extra columns there. Calculate most served. Well, calculate most served would be displayed for every single row, for every single column. So that actually falls under the first few columns. So that's not an issue. However, we would have an additional column for calculating the average served, and we would have an additional column for calculating the rating. This means that we would need plus 1, and so by my guess at this point in time, we are going to need 3 additional columns at this point. I could be wrong, and this is why you should actually do a design in the first place to draw out what it is. All right, so having done the rows and columns, I would next need to label my grid. So before I can label my grid, I would need to write out my usual subroutine. So I'm going to call it PT, by-val R as integer, by-val C as integer, and by-val T as string. Please note, this is something you should really know by now. It's not negotiable. Just memorize it if you have to. Okay, and I've got that. Okay, so remember that there are multiple pay points and there are multiple columns. So I am going to have to then go for P is equal to P as integer is equal to 1 to NPP, next P, and I'm going to go PT P because it's row P, column 0, and then I'm going to go pay point ampersand C string P. Now some of you may have picked up, wait, hang on, can I not just take this? Because look, I've got a 4P loop there, and I've got another 4P loop here. Why can I not just take this and put it inside here instead? I mean, I would be saving code. I would suggest you don't do that. I would suggest you keep these two pieces of code separate. Okay, this section of code is responsible for resizing the array, and this section of code is responsible for labeling and setting up the grid. In fact, I would personally suggest, and please, I'm not saying you have to, but I would personally suggest that you actually create a separate subroutine that sets the grid. All right, and I would then put this code in here instead, and I would do the same for the pay points array. So if I then put it up as a separate subroutine, I would then call set grids, and it would call this instead. So I would have a private subset arrays, all right, and I would put this code here. Over here. Okay, and so I must make sure that I must remember to call set array. So here you can see I'm trying to be modular. I'm going to first set the arrays, and then I'm going to execute the code for setting the grid. So Over here, I have resized I have already labeled my pay points, and then this is yes, JS Photo. I think doing it that way makes it easy to read. That's why I say it is a personal preference of mine. I do like doing it this way so that it is easier to read. I can see that, oh, this section is just to set the arrays and this one is to set the grids. Okay, but as I said, I'm not forcing you to do it the same way as I do. All right. Once I've done that, I'm going to have a separate for loop. Okay. 1 to n counters, and what I would like you to notice is that when we're resizing the array, we have one for loop inside another. But when we're labeling our grid, you notice that the two for loops are separate. Okay, how do you wedge information to display on the grid? Well, the question in your slides actually tells you what you must display, because here you must input, so there's nothing about displaying here. Okay. However, for each counter, calculate, store, and display. The minute you see, oh, this is something, calculate, store, and display, then you know this must be displayed. Calculate, store, and display. This must be displayed. So these are the things that tell you what information has to be displayed. All right. So that's why you'll notice that I am putting in pay point information and counter information, for the reason that here it says for each counter and each pay point, calculate, store, and display. That means that it will be information relating to every counter at every pay point. Okay, so over here, I'm going to go PT, and remember this is going to be my columns. So it's row 0, column C, and then counter ampersand C string C. Now, based on my mental calculation, I remember that after each pay point, I also have to display on column 0, row 0, column, and now you go, well, it's actually in counters plus 1, and you might say most served. All right. Maybe I must actually put this down here instead. This is after our counters. And then there was also a rating that we had to display. So I would go PT0 in counters plus 2. And we put in a rating for each pay point. Okay, and at this point, if you want to make sure that your grid looks correct, what I would suggest you do is you can run your program and just see whether it more or less displays correctly. Okay, so there we go. I'm going to, okay, hang on. Let me just move the window here. All right. So over here, maybe I'm going to make an, and remember in our design, we said we're going to have 2, 3, 2, and we're going to initialize the program. And oopsies, we can already see that this is a system null reference exception. Object reference not set to an instance of an object. Now, this is because when we resized our array, our first array here, we resized it to NPP, and earlier AR Ogden actually pointed out that we would have an issue because the first counter that we're trying to go to now doesn't actually exist because we only did it for the third counter. So we're going to press stop there, and we're going to change that to P. We're going to press start, and let's run this again. Okay, so it is 2, 3, 2. Initialize our program. You can see that there's 2 pay points and 3 counters plus a most served column as well as a rating column. And if you are not sure that this is correct and you want to make sure that this is definitely, I would then alternate the values and see that, okay, now there's 3 pay points and 2 counters, so it is correct so far. All right. Okay, any questions at this point with regards to setting up our grid and answering question 2? No questions? All right. we're going to move on to the next question, because we've effectively answered question 1, well, question 2 there. All right, question 1 was setting up the record structures. Question 2 was initializing the program. So now let's input data. Okay, so this is question 2. All right, then remember with question 2, you're going to have to read in all the necessary information, which is the location of each pay point, the rent for each pay point, the name of the staff at each counter at each pay point, and then for every day at each counter at each pay point, how many people were served. Yes, I know. Well, yes, I did answer that question. I said, the question was, how do you fetch information to display on the grid? And I answered it by saying that you have to read this question to see where it says display. So if it says, so you'll notice that up here they don't mention anything about display, but from question 4 they actually say calculate, store, and display the most people served in a day. All right, but that's okay. Don't worry. Let's not every. I think all our internet connections are a little wonky sometimes. Okay, so this is not. Well, is this question 2? No, this is question 3 now. Sorry. Okay, because we answered question 2, this is question 3. And as I was just saying, we want to input information for each day, for each counter, for each pay point. So right off the bat, I'm going to now do it a little differently from how I've been doing it up here, which is where we declare P as integer, C as integer, and D as integer. Okay, I am now going to do it differently here. Please note, for your purposes, stick to one style. Okay, it's a bit weird if you use different styles, but what I will do now is I'm going to use the old way of doing it so that you can see the difference between the two. Okay, so I'm going to have a P for each pay point, C for each counter, and D for my days. And I'm going to already declare P is equal to 1 to NPP. All right. And inside the P counter for loop, I'm going to have for C is equal to 1 to N counters. And then inside that, I'm going to have for D is equal to 1 to N days next T. Okay, so I know I'm going to use all 3 for loops, but you must make sure that your use of input boxes is in the correct for loop. Because if you are not sure and you now shove everything inside here, and I'm going to do that quickly now, I'm going to write all the code and I'm going to shove it all inside all 3 for loops, we're going to see what the issue is. All right, so pay points. Now the first thing we want to ask is pay points P dot location is equal to input box, and I go what is the location? All right, and maybe if you want to, you can say pay point C string P, so that you can see exactly which pay point we're looking at. Okay, let's see what it's moaning about. Oh right, we're not called location, it's called lock, I believe. Yes, lock. Okay, and then we're going to have pay points P dot rent is equal to, and this one we need to use cint because it is an integer. What is the rent for pay point C string P? Right, and after that we would ask for what is the staff name. So we got pay points P dot counter C dot staff is equal to input box. What is the name of staff at counter C string %C of pay point? Please note, you don't have to make it this detailed. This is not necessary, all right? But I just like to do this so that I can see exactly where I am when I'm inputting information. And then the final thing we have to enter is pay points P dot counter C dot P served D is equal to C int input box, how many people served on day, ampersand C string D, ampersand at counter, ampersand C string C, ampersand of pay point, ampersand string P, ampersand question mark. Alright, so this effectively allows us to read in all the information, because remember, we're only interested in reading in the location, the rent, the staff, and the people served. So I've now mistakenly put in all 4 lines of code inside all my loops. At this point in time, you should already know that this is going to be horrendously wrong, for the reason that line of code, which index variables are we using here? You can see that we only have P. See? P. There's no C, there's no D. That should give you an indication that that has no business inside a for C loop, nor inside a for D loop. This one, same thing, only P. So it should only be inside a for P loop. This next line has a P and a C, so this line should only be inside the for P loop and the for C loop. And this one, P, C, D, this one should be inside all 3. But if we were to run it, you'll soon see what the issue is. And this is very aggravating when we are marking that this happens, because the assistant then goes through the trouble of having to enter the information in repeatedly. Now, what I mean by that is this: input information. Okay, what is the location of pay point 1? So you go, okay, it is A, according to our test data. What is the rent? Okay, I can't spell. What is the rent for pay point 1? And you go, well, it is 1. And what is the name of staff at counter 1 of pay point 1? And you go, well, it is A1. That is the name of the staff. And how many people were served on day 1 of at counter 1 of pay point 1? You say, well, 10. Now, after I enter 10, what should the next input box ask me? It should surely ask me how many people were served on day 2 at counter 1 of pay point 1, right? Instead, it's asking me what is the location of pay point 1. And the reason why it's doing that is because all your code is being repeated. So this is very wrong, and this is very tedious. So I'm going to quickly change rent here, and I'm going to take these 2 lines of code, and I'm going to follow my strategy that I mentioned earlier, and I'm going to say that actually needs to be inside the for P loop only. And this line of code should be inside the for C loop, which is inside the for P loop. All right, so this, ladies and gentlemen, is what really happened, not what we saw earlier. Because if we then run this now, we will see 232, initialize, input data, and we're going to do this again. Location is A, rent is 1, A1, 10, and now it actually asks what is how many people served on day 2. So we got 15, and then the next thing it actually asks us is what is counter 2, which is what is the name of staff at counter 2, which is A2, and 120 and 16. So you can see that this is actually now correct. Now I'm not going to proceed because this is just capturing the data. So let us move on to calculating the most served. So this is question 4. And the question for most served is we need to look at this particular array here, P served D, and find out what is the maximum value and store that in M served. So that means we would have to navigate through a P loop, a C loop, as well as a D loop. And that is why I'm going to have P, C, and D as my index variables again. So for P is equal to 1 to N PP. And some of you might be quite tempted to, at this point in time, copy your code. Please don't do that. Okay, this is, if you copy your code, quite chances are you might actually end up having errors as a result. Now, this question is quite different from the maximum question that we answered in lecture 19. What we need to do here is we need to consider, so yesterday when we went through the algorithm, we said we needed to find the maximum inside one array. But this particular question is different in the sense that we want to find the maximum in that array, right? That array is inside an array of counter, which is inside an array called pay points, meaning we need to find a maximum inside 3 different arrays, which is the reason why for question 4 here, I have 3 for loops, and now I must go into the innermost for loop, which is this one. This is going to be the for loop that navigates through the array I'm interested in finding the maximum of. And before I start on that for loop, here at this point, at this insertion point, at line 60, I will then declare my maximum value. Now, mserved is a maximum value. So we're not interested in knowing where the maximum is. We want to know what is the maximum. So I will then say pay points p dot counters c dot mserved is equal to pay points p dot counters c dot p served 1. Okay, so that's the maximum value that I've set. And then over here, I will have the if statement to say if my pay points p dot counters c dot mserved, because remember mserved is the variable storing our maximum value, is less than pay points p dot counters c dot p served d, then, and I'm going to be lazy here, I'm going to copy that, that is equal to that. Right, just like this. So effectively, your maximum algorithm is here. You are applying your maximum algorithm in these few lines of code. These 2 for loops, however, are being used to ensure that we do this maximum calculation for every counter for every pay point. So what you realize is that at the end of the day, regardless of where we ask you to find the maximum or the minimum, the algorithm is the same each and every time. The only difference is how many for loops do we wrap this up in. Right. So over here, once we've actually found out what the maximum is and we've exited the for loop, we will want to then display our results. So we've got pt, open bracket, p, because it's on row pay point p, and column counter c, and we now say c string pay points p dot counter c dot m served. Okay, just needs another bracket, and this would then display our first set of information. So note that we're not displaying the information of how many people were served per day. Okay, let's just do this. 232, input our data, A, and then 1, and then A1, 10, 15. And please note, I'm actually using the test data that I have put in previously. Okay, A3, 15, 18. What would change to get the minimum? Okay, I'll do that now. What is the location of pay point B? 2B, and then 2B1, 11, 12, B2, 13, 15, B3, 99, 14. And then when we calculate the most served, you can see now that is displaying the most served value. So this is the first time we're displaying anything. If we need to find out how to change to get the minimum instead, I'm going to click close. It is simply that. Right. So when we change it, we are then saying if this value is bigger than the current value we've got, that means that this one is actually smaller than this value. And so this value must update itself to be this value instead, proceeding down the rest of the way. And for those of you who are very adventurous, you will know that technically you can change this value to what? Any ideas? Yes, 2. Okay, so you can change this one to 2. Can I change these values to 2? Would I be able to change these 2 values to 2? No, absolutely not. Right, because if you do, then you would not look at every single pay point and every single counter. Now, ML11 asks, when looping through the structure array, would using a for each loop instead of a counter variable be a good alternative? Well, please don't use for each loop at this point in time. We haven't actually taught the for each loop in 1A. We actually only teach the for each in 1B. So if you use the for each, that would be wrong at this point because you have to use the tools that we give you. All right, so please don't use the for each. All right. Okay, so that is question 4 answered. So let's move on to calculate the average spend. And the average spend is, how do we work out the average spend? Well, we want to know of the M values there, which of these M values is, let's take these M values of each counter and we want to work out the average of it. That means, do we need to go through, how many arrays do we need to go through? We only actually need to go through a P4 loop and a C4 loop to go through each counter's M-serve for each pay point, and that is why for question 5, we are only going to have P and C as integer. We're not going to have a D anymore because we don't need to go through the days array. Well, the P served array. So we go for P is equal to 1 to N P, next P, and then for C is equal to 1 to N C. Well, in counters, next C. And over here, just before we enter our counters loop, what we're going to do is we're going to declare a total as integer. Okay, and we're going to initialize this total equal to 0, because remember, to work out the average, we need to add up all our M-serve values and then divide it by however many counters there are. So total will then be total plus equal pay points P dot counter C dot M served. Right. And once that is done, after we have exited the counters, so we've added up all the counters M-serve values, we will then say pay points P dot MAV is equal to total divided by N counters. Now remember, this is, once we've worked this out, we want to display it. So we go PTP, right? And column N counters plus 1, because it needs to be at the last, well, the second last column. And then we need to use the format command because it is up to 3 decimal places. So we go pay points P dot MAV 000. Okay, and that will display it. Now I'm not going to run this. I'm going to go continue with the calculate the rating. But remember, in order for us to calculate the rating, actually, how are we for time? I think we are. Actually, time is almost up. Mr. Labia, what are we looking at for time?
Still have 10 minutes.
10 minutes, okay. Roundabout. So we can rush through this, all right? But if you have any questions, please feel free to post it under Discord or type your questions as we go along. I am going to quickly type out the code for the question 6. All right, now question 6, remember, is a subroutine. And with the subroutine, we are going to have to call it calculate rate, and we have to call it our first parameter input of type double, but we know that it's going to return a string, and we can call that whatever we want. So with that in mind, I am going to quickly go here and let's double click on that. But remember, we're not writing the code for the button yet. We're going to write a separate subroutine. So I'm going to go private sub, and let me just go back here. It says it must be called calculate rate. All right, so calculate rate by val. Remember, the first parameter does not have to be by ref. It can be by val. Okay, input as double. Now, as most of you have earlier indicated, is it by ref, and you can call it whatever. So I'm going to go output. I'm going to call it output as string. Okay, and then inside here I'm going to have a select case, and the select case is select case input because I'm comparing the value input. And my options here are, and this is important, 0 to 50, which is bad. All right, so we go case 0 to 50, and then what happens if it's case 0 to 50? Output needs to be bad. And then now you can say, well, case, and now here's the tricky thing. They say in between, and you can't really do in between for a select case, can you? But what you cannot also do is you cannot do an else. And the reason why I say you cannot use an else is I'm gonna now point out to you. Okay, I'll point it out to you now. The next one is the more than 80. So I want to look at the more than 80 first. So over here, go back to here, and we say case is greater than 80. All right, and that would be output is equal to excellent. But if we had said case else, what would the error then be if we had left it as case else? Any ideas what the issue might be? And the point, you know, if you've got the answer, good for you, or you can compare your answer with what my answer will be. But if you use case else in this situation, the issue then becomes that if someone had the value -1 or negative anything, it would also be output as good. And that's not something we would like to have. All right. But note the following. In between is what value exactly? Now, if this was an integer input, we could have said case 51 to 80. We could have done that. But this is a double. So if it's a double, if I said case 51 to 80, the error then comes in if my value was 50.5. So how then do we actually address this issue? Well, remember that a select case works according to what it matches first. So if the number had been 82, it would have said, is this the case? No, it isn't. Case is greater than 80? Yes, it is. 82 fits into this qualification, so we'd go excellent and would exit this select case. So what I would suggest you do is I would say case is greater than 50, because if you do this, then think of it this way. If the value was 50.1, does that qualify? No. Does that qualify? No. And then it would go here and it would give you the value good. All right. This is a kind of new work that you're going to have to think about a little, but please consider this section. This is quite important. Okay, so I've actually written my select case, my subroutine. What I would also do is I would say question 6. Okay, and now moving on to question 7, which is this actual button, question 7, and this is where I'm going to use this calculate rate. And how many times do I need to call the calculate rate? Well, I only have to actually do it for 1. So I'm going to say for p as integer is equal to 1 to npp, next p, and I'm going to call this subroutine. And remember, it's not a function, so to call the subroutine, I actually have to go calculate rate, open bracket, and what value am I going to pass to it? I'm going to pass to it pay points p dot mav, that is the average I want to pass. I say, please compare this average for me. And once you've compared the average, you need to store the answer somewhere. Where do I want you to store the answer? I want you to store the answer in pay points p dot rating. Okay, and that, ladies and gentlemen, is how you would call the subroutine. But you also want to display it, and that is why the next thing I do is pt p, because it's for pay point p, column in counters plus 2 now, and then I would not have to C-string anything because pay points rating is a string. So I'm going to go pay points p dot rating, and that effectively would be our code for question 7. So you can see that question 7 doesn't really do much, but that's because most of the heavy lifting has been done in the previous sections. So let's go through this again. 2, 3, 2, run our program, input our data. Again, I'm going to have the A1, 10, 15, A2, 120, 16, A3, 15, 18, B2, B1, 11, 12, and please note I'm only doing it very quickly because I've got the test data in front of me. 13, 15, B3, 99, 14, calculate most served, 10, 11, and the idea is what you need to check is that you, oh right, we're working out the minimum now. We changed the code to the minimum. So it's 10, 11, 16, 13, 15, 14. I'm not going to change it now. I'm going to press. There is my averages. So unfortunately, because it's the minimum, these both should be bad. So let's go back to our minimum and change that to our maximum again. And now we're going to have to, okay, yes, there's actually a question. Please ask your question. Yes, please ask your question. Just unmute your mic and ask your question.
Prof.
Yes.
I have connecting problem here. Are you going to upload this on Eve today?
Yes.
Because
Yeah. Well, not on Eve, on Blackboard. I'm going to upload this video to Blackboard.
Okay. Thank you.
All right. Thank you. Okay. So yes. JL Mabaso, please ask your question.
Oh, my question is under in the grid, like under the pay points and the counter, are we displaying the maximum or we're displaying what's this, the inputs we're putting in? Because they ask us like for day 1, let's say it's 5, then day 2, let's say it's 10.
Yes.
Are we displaying the sum of both of the days, or are we displaying the minimum or maximum?
No, if you read the question very carefully here, you will see that question 4 is where we start displaying, and it says for each counter at each pay point, calculate, store, and display the most people served in a day. That's the first time you display any of your work. So in other words, you are displaying the maximum amount of people served in a single day for each counter, for each pay point.
Oh, I think the complication was like with the labeling of the grid.
No, if you look at this, look carefully. Okay, so we got 2, 3, 2 here, and that is the maximum number served at counter 1 for pay point 1. The maximum people served at counter 2 for pay point 1. Since I think for now we've been going on about, we've been reiterating that if we want to display the number of people that are served each day at each counter, at each pay point, that is not possible in a 2D array, because number of people served per day, per counter, per pay point is 3-dimensional. You cannot display that.
Okay.
And
Because
right.
after counter 3, you wrote most served as a label. So I think that's where I got confused.
No, but most served is a most served average. If we see, this is based on the question
Okay.
here. Look, that's question 5. It says for each pay point, calculate, store, and display the average most people served. That's why I think your problem is I think when you get these questions, you must make sure you read the question carefully so that when you put in your inputs and your outputs, you know exactly what it is that you need to display. Because most semester test questions will be like this. There will be certain similar concepts, and there is a difference between average served and the average most people serve. I don't ask for any averages here other than the average most people serve, which is just calculated in the previous question before.
Oh, thank you.
Okay. All right. So if I just quickly show you now a 1, A1, 10, 15, A2, 120, 16, A3, 15, 18, and B2, B1, 11, 12, B2, 13, 15, and B3, 99, 14. Let's see if it matches our test data. And yes, it does. 12, 15, 99, 15, 120, 18. So there are our averages up to 3 decimal places. And you can see good and bad. All right, so that good proves that my subroutine has actually been set up correctly, but order is very important. Anyway, we're out of time. Thank you, ladies and gentlemen, for attending. All right, please, we will record, we have recorded this, so we will upload this recording. Well, you can download this recording yourselves of Blackboard, but you can also, we will also make a smaller version of this downloading on Blackboard under the downsize video section, and we will save an audio recording. All right, thank you very much. Please enjoy this long weekend and stay safe.